Alright guys, welcome to Algebra 2, Chapter 5, Section 1.1. So today we're going to do a little bit of an activity to kind of start off here, somewhat of a game here. So normally we do this as kind of a race in class, but if we're at home, I'll just have you kind of do it on your own here. So no real time limit. What I'm going to do is I'm going to show you a kind of just problem. You want to try and figure out what the solution is, and you can try and do this in your head, but if you need to write things down, that is more than fine, and if you want to use a calculator, I'm fine with that as well. So once you kind of see the first one, you'll kind of see how these all work. So when I subtract 3 from my number and then multiply the result by 5, I get 45. What is my number? Okay. So this is the guess my number game. So however you want, try and figure out what that is. Go ahead and pause the video, and then once you think you have your answer, go ahead and come back here, and I will tell you the answer, and we'll try it 1 or 2 more times here. Okay, so what you should have gotten here was 12. Right? So take 12 minus 3, and you get 9. 9 times 5 will give you that 45. All right, let's try it one more time now that you kind of get how this works. Next one, when I divide my number by 4, then add 17 to the result, I get 25. What's my number? So go ahead and pause and try and figure out that answer. Okay, so this one is actually 32. So take that 32, I divide it by 4, and then add 17, and I end up getting that 25. And then we'll do one more here. For this one, when I square root my number and then divide the result by 3, I get 2. So what's my number here? All right, so this one you should be getting 36. So square root of 36 will give you the 6. Divided by 3 gives you that 2. Right? So the big point here that we're trying to look at is what strategies did we use to kind of solve this out. Now, you may start by just kind of like guessing, checking, like, well, if I plug in this, does it work? If I plug in this, does it work? Do I need to plug in a larger number, plug in a smaller number, stuff like that. For this last one, you may say, well, it definitely needs to be a perfect square, so I'll try 9 and 16 and 25 and so forth, right? Those are all good strategies. But what you may have done, which is the kind of most efficient way, is kind of working backwards here, right? So let's take this last problem. If I end up with 2, right? To get that 2, I divided by 3. So to undo that, I would multiply by 3. So 2 times 3 gives me 6. So I'm at 6 now. But then the step prior to that was I took a square root. What's the opposite of a square root? That's a square. The square of 6 is 36, and there's my answer right there. And you can try that for these other ones too. So let's try it for the very first one. I get 45, right? I multiplied by 5 to get that, so well, let's divide by 5. So 45 divided by 5, that gives me 9. And then to get the 9, I subtracted 3. So let's add 3 to undo that, and now I'm at 12. Great. So go ahead and try it here for this one if you haven't yet. So go ahead and pause, try and do it that kind of opposite way, and see if you can get the 32 answer we are supposed to get here. Okay, so if I take my 25 and I subtract 17 from it, I end up getting 8, and then 8 times 4 gives me the 32 that I started off with. So there we go. So that's just kind of what we're doing. Now, you've been doing this kind of stuff quite a bit in the past. You've just been having it in this way. This is how you've solved algebra problems, right? If I see x plus 1 is equal to 2, I subtract 1 on both sides to undo that plus 1. So this is effectively that, right? Now what we call this process is these are inverses, right? You've probably seen and heard of inverses in the past. This is a kind of more formal way to kind of go over that entire process. So what I want you guys to do now is you're going to do problems 2 through 6. These are fairly self-guided. You shouldn't have very many problems here. If you do, I'm going to put up the answer key here in a second. You can check that. If you're still having some questions beyond that, you can contact me via either email or a GoToMeeting if that helps too. So with that, go ahead and pause. Work on 2 through 6. Once you feel like you've got it, go ahead and come back here. I will be posting up the answer key here in a second, and you can check your answers there. All right, so here are our answers. There we go. All right, so problem 2, there's our solutions there. Problem 3, and here's 4, 5, and 6. So for some of those, it says like the answers may vary, stuff like that. Those are more questions about you just kind of thinking about it and being conceptual. As long as you feel like you really got that and and what they're saying kind of makes sense to you, you're probably doing fine. If you made an error, go ahead and look back at your work and see if you can correct that. And if you can't, please try and contact me via email or go to meeting, and we will try and cover that for you. Okay, with that, let me minimize this, and then we'll go on to the closure. So I just want you to think about what strategies you liked and what strategies were good for finding an inverse equation. In general, one of the really common ones which we use is we take the x and the y variables and we transpose them, meaning we switch their places and then solve for y. So we can actually go and do one of those. Let me pull this up. Let's go back to this. So let's go ahead and do like problem 5. We'll do slightly more complex one. We'll do C, which is y equals 2 times x plus 3. Is that a third power? It's really small. I think it's a third power. Yeah. Okay, so let me go ahead and start my document camera. All right, so we're trying to find the inverse of this. So this is technically like f of x, right? But I'm going to call it y just because it makes it a little bit easier to transpose here. So you can do this transposing either at the start or at the end. It doesn't really matter. I typically do it at the very start because then I know I'm trying to get y by itself and I don't forget about it later. So I transpose. So x equals 2 times y plus 3 cubed. Okay. So at this point, it's just a basic algebra problem. You're just trying to get y by itself now, right? So you know how to do all of these steps. Just go through the process, right? So what do I do with this 2, this 3, or this 3 first? It's going to be the 2 because this is being multiplied, and I have to get rid of that before I can start to deal with this stuff here. So I'm going to subtract 2. So x minus 2 equals y plus 3 cubed, right? And then to get rid of that cube, I want to do a cubed root. If it was a square, I would do a square root, stuff like that. Equals y plus 3. And then how do I get rid of that plus 3? Well, I subtract 3. So that's the cubed root of x minus 2 minus 3, which is not underneath that radical, equals y. So now I've found my inverse. So how I can denote that is we use this symbol for the inverse. F raised to the negative x is equal to, your book might say stuff like negative 3 plus the cubed root of x minus 2. That's only because we try and avoid putting things after radicals because it can be a little bit ambiguous as to, well, is the negative 3 under it or is it not under it, stuff like that. Just kind of depends on how you write it. But hopefully we see how this and this are the exact same thing, right? So again, this is our symbol for an inverse. It does not mean raised to the negative 1 power. That's one thing that I really hate about that being our symbol for inverses. If it were up to me, we would not use it, but that's just how every mathematician does it, so we just gotta kind of follow suit there. All right, so that's the kind of general process which I hope you got. Now there's other ways. This is the one that I much prefer. It's very systematic, and you can just kind of follow that same process every single time, and you should be fine there. Okay, so with that, here is our homework for 511. We're doing 8 through 15, and I will talk to you guys next time.